2.2, the graph of a function. So what is the graph of a function? The graph of a function is when you take this set of data, with all of your domains and all of your ranges, and you plot each and every single point so that it turns into a visual of all that data. Now, how do we know that this graph is indeed a function? So there's something called the vertical line test. The vertical line test basically means that if you were to draw a vertical line anywhere on the graph, it would only intersect one point. And it seems to be true for this graph, this means that this is indeed a function. Now, which one of these are functions according to the vertical line test, and which one of these aren't? So let's look at A. They've drawn some dotted lines here for us, and it seems that no matter where you draw a line, the graph will only intersect the line at one point. Same thing goes for B, only intersects at one point. Now C intersects at 2 points, so this means that C is not a function. And D also intersects at 2 points everywhere you draw a line. So this means that D is also not a function. Okay, so like we said earlier, graphs are the visual representation of a set of data. Now that set of data can be anything from how far the tides come in every day, or the distance at the bob of a pendulum from its at-rest position. So, seeing as this is the case, we want to be able to use a graph and to get information from that graph. So if we look at f of 0, f of 3 pi over 2, and f of 3 pi. So at f of 0, we're right here. At f of 3 pi over 2, we're right here. And at f of 3 pi, we are right here. So this means that f of 0 is 4, f of 3 pi over 2 is 0, and f of 3 pi is negative 4. Now those are just points, but what can they tell us about the graph? So let's start by finding out what our domain is. So, since these 2 points at the end are solid points, and there's no arrow going past it, it means that from here to here is the domain. So the domain would be x from 0 less than or equal to, since it is a filled in dot, to what is that? 4 pi. Since this is also a filled in dot. So that is the domain. Now, what is the range? So the range would be the highest value for y and the lowest value for y. So if we were to draw a line here and here, we would see, or right here, that the highest value would be 4 and the lowest would be negative 4. And since the points there are also filled in, less than or equal to, greater than or equal to, and that is your domain and range. Now let's go ahead and try and list all of the intercepts. So intercepts are where the graph crosses or touches either the y-axis or the x-axis. So if we look on here, it would be this point, this point, this point, and this point. So why is it not these points? Because none of those touch an axis. So then if we were to list all of those green points, it would be 0, 4, pi over 2, 0, 3 pi over 2, 0, 5 pi over 2, 0, and 7 pi over 2, 0. So, which one is an x-intercept and which ones are y-intercepts? This first one, that is a y-intercept because it touches the y-axis. The rest of these are all x-intercepts, since all 4 of them are on the x-axis. Okay, so if we just look at the graph once again, when does f of x equal negative 4? So it equals negative 4 at pi and 3 pi. Now, when does it equal 4? So we see that it equals 4 at 0, 2 pi, and 4 pi. So we can kind of see that there seems to be a difference of pi between each coordinate. So it starts at 0, and then at pi it's negative 4. Add one more pi, it's at 2 pi and it's at 4. The next pi, 3 pi, it's at negative 4. And the next pi, 4 pi, it's at 4. So then for what values is f of x greater than 0? And for what values is f of x less than 0? So, if we kind of look here, greater than 0 would be this portion, and this portion. And less than 0 would be this portion and this portion. So, from 0 to pi over 2, and then from 3 pi over 2 to 5 pi over 2, and then from 7 pi over 2 to 4 pi. And for the less than 0, it goes from pi over 2 to 3 pi over 2, and then from 5 pi over 2 to 7 pi over 2. So, f of x greater than 0 written down would look a little something like this. So, from 0 to pi over 2, and from 3 pi over 2 to 5 pi over 2, and from 7 pi over 2 to 4 pi. So what do the brackets and the parentheses mean? Brackets, these two, were used because on the graph, here and here, the point itself is included because that point is also positive. Whereas this point right here, pi over 2, was given a parentheses because it cannot be included since it is neither positive nor negative since it is at 0. Now these little U thingies, they mean and. Basically just telling us that it's this one and that one. Let's try and take this equation, f of x equals x plus 1 over x plus 2, and try and find the same kind of information that we did using the graph earlier. So, let's say we take a random point, 1, 1/3. How do we know if 1, 1/3 is on the graph of this function? So, very easy. We plug 1 in for x, so we find f of 1. So, 1 plus 1 over 1 plus 2, so that's 2 over 3. So this tells us that although there is a point 1 2/3, there is no point 1 1/3. Now let's say we wanted to see what f of 3 is. So plug it in. 3 plus 1 over 3 plus 2, that's 4 over 5. So now we know that there is a point 3, 4 over 5. What about if we wanted to know when f of x equals 4? So we plug 4 in for f of x. 4 equals x plus 1 over x plus 2. Now, in order to undo this fraction, we multiply both sides by x plus 2. So on this side, it would cancel out, and on this side, it would simply multiply. So 4 times x plus 2 would equals x plus 1. So distribute the 4. 4x plus 8 equals x plus 1. Now subtract x from both sides and 8 from both sides, and we get 3x equals negative 7, which means that x equals negative 7/3 when f of x equals 4. So now let's put what we just learned into a more practical application. So say this function, this funny c with the line over it, x equals the average cost of manufacturing X computers per day. And this is the function that we would use to find the average cost. So let's say we wanted to find the average cost of 40 computers. We would simply plug 40 in for x. 0.56 times 40 squared minus 34.39 times 40 plus 1212.57 plus 20,000 over 40. Looks complicated, right? So we could plug this whole thing into our calculator, and then if we had to find it for 30 or for 50, we would have to plug the whole thing in all over again. So here is an easier way.